Very good morning to you all of my friends. Today I am going to discuss the third part of our lecture, that is the structure of various monosaccharides like glucose, fructose, mannose, galactose. They are chain structure, open structure, they are closed structure or ring structure, etc. In our previous two videos, in the beginning one, we have discussed about the definition of carbohydrates, their classification and importance. These are very basic topics and also important. In our second part, we have discussed another important concept, that is types of isomers and isomerism. From the point of view of carbohydrate chemistry, isomers and isomerism plays a very significant role, and this is our third lecture. Our third lecture is very important, and I think it will be very interesting because during exam hours, before 1 to 2 days of the final exam, students find very much difficult how to remember all of the structure: D glucose, L glucose, D fructose, L fructose, D galactose, L galactose, D mannose, L mannose, etc. Chain structures, ring structures. They get confused, they get exhausted. So I have think to give some easy tricks to you so that you can remember it very quickly and there will be no confusion during your exams hours. And another thing, this is my third lecture and I feel very much lucky that I have received feedbacks from your side. The first feedback is that my board is not properly focused in the camera. It is not in a 90-degree angle. Sorry for that. Actually, I am using a tripod only to make all of these videos. I have no technical assistance, no cameraman. I just hold my camera on the tripod and I draw all of these structures. I discuss these concepts. So it is very difficult me to maintain the positioning of the camera during the video. So pardon for this. Second one is about my tone, my modulation. So from this video I have discussed to change my some root or monotonous tone. And the third one is clarity of the diagram. Okay, from this video I think I'll draw it in the board and I'll discuss so that there will be lack of unclarities in the board. So let us discuss about the various structures of monosaccharides. Basically there are two structures of monosaccharide. The chain one, it is also known as open structure, chain structure or open structure, and the second one is ring structure or closed structure. Chain structure, if we represent the carbon atoms and functional groups in an open chain, then it is known as the chain or open structure. And if we represent the monosaccharide in a closed ring-like structure, then it is known as ring or closed structure. Now first we'll discuss about various chain structures of various monosaccharides and its isomers. Regarding this chain structure, there is something important, the D and L configuration. Let us clear what are the D forms, what are the R forms. When you will say that this monosaccharide is present in D form, and when you will say it will present in L form. Actually, this D configuration and L configuration is derived from the configuration of the glyceraldehyde molecule, the Aldo sugar. This is the glyceraldehyde molecule, CHOH, CH2OH. This is the glyceraldehyde molecule, and remember this is the diglyceraldehyde. This is the glyceraldehyde molecule. And another one. Another one is L-glyceraldehyde. If this is diglyceraldehyde, then this is the L-glyceraldehyde molecule. This is the L-isoform. L-glyceraldehyde. Now, when we'll represent a monosaccharide in D or L configuration, then always remember the functional group, the aldehyde group, should be on the top position of the same structure. It should not be like that. It should not be like that. Okay? It should be always like this one, not like that one. Functional group or aldehyde group should be present in the top position of the same. Second one, what is the bottommost chiral carbon atom for glyceraldehyde molecule? As glyceraldehyde has only 3 carbon, so this will be the second carbon will be the bottommost carbon, this one. In the bottommost carbon, if hydroxyl group D and L configuration is related to the hydroxyl group, if it is present in right side, here it is present in right side, then it will be diglyceraldehyde. And look, the second one, here OH group is present in the left side, therefore this is L-glyceraldehyde. This is the D and L. Now, some student will say that as OH group is present in left side, this is the bottommost chiral carbon atom, and here OH group is present in the left side. Okay? So it is the L-glyceraldehyde, but this is not correct, because I have previously mentioned that functional group should be in top position. Here it is in the bottommost position. So if we take a 90-degree rotation to follow this rule, so that functional group should be present in the bottommost position, 90-degree, it will be here, then again it will be here again, 90 degree, 90 degree, 90 degree. If we take a complete 360-degree angle, then OH group will be present not on the left side, this right side, 360-degree angle. So it will be diglyceraldehyde, not L-glyceraldehyde. However, we always represent this one, the functional group, the aldehyde group, on the top position, while we are designating various kinds of monosaccharides as D or L isomers. The second one, this is clear. I think this is clear, D and L configuration. The second thing, how to remember all of this: D-glucose, L-glucose, D-galactose, L-galactose, D-mannose, L-mannose, D-fructose, and L-fructose, all of this same structure. There is a very easy trick. You have to remember only one same structure, that is the structure of D-glucose. Else, you have to relate with this structure. With this D-glucose structure, you have not to remember all of this structure. If you know how to draw this D-glucose structure, then you can easily draw all other D and L isoforms of galactose, mannose, etc. Now, this one is our D-glucose. Let me draw the structure of the D-glucose. This is the first carbon. CHO. Then this one is the second carbon, CHOH. This one is the third carbon, COHH. This one is the fourth carbon, CHOS. This one is the fifth carbon, CHOH. Now, as the sixth carbon is CH2OH. CH2OH. So, this is the bottommost chiral carbon atom. This is the bottommost chiral carbon atom. So, reverse of this is the L-glucose. This is the D-glucose. For L-glucose, you have to remember only the structure of D-glucose. CHO, all of these are same. CHOH, third carbon atom, COHH, same. Fourth carbon atom, CHOH, same. But fifth carbon atom, this is the bottommost carbon atom. And in L configuration, in the bottommost carbon atom, OH should be in the left side. So, this is the structure of L-glucose. While you have given any kind of monosaccharide, while you are going to ask to draw any form of L monosaccharide like galactose, mannose, glucose, only you have to place the OH group in the left side in case of the bottommost chiral carbon atom. Now, how to remember the structure of D or L mannose and D and L galactose? Do you know what is epimers? Epimers are the isomeric form or isomers which are structurally different to each other only with respect to one isomeric center, with respect to only one isomeric center. Now, when you are going to ask to draw D mannose, what you will do? You have not to remember all of this structure. You have to remember only this one, D-glucose. Remember one thing, D-glucose and D mannose are epimers with respect to the second carbon atom. Okay? So, the first carbon will remain same, like D-glucose. And this second carbon, it is the turning point. There will be the difference, as it is epimer of D-glucose with respect to the second carbon atom. So OH will be in the left side, H will be in the right side. Here, this will be the only difference. Others will remain same. COHH in the third one, COHH in the fourth. CHOH in the fourth one, CHOH in the fifth carbon atom, and CH2OH. This is D mannose. This is what? This is D mannose. If you are asked to draw L mannose, you have not to change any other thing. Only you have to flip-flop this. You have to draw this OH group in the left hand side and H group in the right hand side. This is L mannose because this is the bottommost chiral center. So this is the easy trick how to draw D mannose, L and mannose. Now another important monosaccharide is galactose. Now, how to remember the structure of galactose? Few minutes ago, I have told that D-glucose and D-mannose are epimers with respect to the second carbon atom. Now, you can guess D-galactose and D-glucose are isomers of which carbon atom? It is about the fourth carbon atom of the open chain. So, first carbon atom will be first carbon atom, the configuration of the first carbon atom will be same. The second carbon atom will be also same. Third carbon atom configuration will remain same. Here the difference come in the fourth carbon atom. In this one, fourth carbon atom, OH will be in this side, left side. H will be in right side. Then again, fifth one will be same, CHOH. Sixth one will be also same, CH2OH. This is D-galactose. What is this? This is D-galactose. And if you are asked to draw the L-galactose, you have to do nothing. You have to flip-flop again this OH and H. Now it is L-galactose. These monosaccharides same structure: D-glucose, L-glucose, D-mannose, L-mannose. D-galactose, L-galactose are very important from the exam point of view. These are Aldo sugar. Now, there is one important ketose sugar, that is fructose. Now, how you can remember and how you can draw the structure of D-fructose and L-fructose. Fructose is a ketose sugar, so structure will be something different. The first carbon will be CH2OH. The second carbon will be C double bond O. As it is a ketone sugar, therefore functional group, the ketone group, will be present not on the bottom position or the terminal position of this chain. It will be present in any of the middle position. Here it is in the second position. And the third one, from here, the entire structure is similar with D-glucose. COH, CHOH, CHOH, CH2OH. For D-fructose, from the third carbon, this will be similar to the structure of D-glucose. Only this part will be different, this part will be different. And in case of L-fructose, you have to only flip-flop this one. OH, H, and L-fructose. Now, we are going to discuss how to draw the ring structure of the aldose sugar and the ketose sugar. For aldose sugar, like glucose, how to draw the ring structure. To remember the ring structure, again you have to remember only one structure, that is of D-glucose. This is D-glucose. CHO, CHOH, COHH, CHOH, CHOH, CH2OH. This is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 5, and this is the carbon number 6. Now we can draw this aldehyde group, the present in the carbon number 1, as C double bond OH. This one, C double bond OH. Now we can draw the ring structure from this structure, and it will be like that. This is the carbon number 1. So OH, you can draw it like this. Okay, you can also draw it like this one, COH. This is carbon number 1. Then this is carbon number 1, this is carbon number 1, this is carbon number 2. Left side uppercase, right side lowercase. This is 2. This is 3. Lower uppercase, lowercase. 3. Again 4. H. 5. Here, this one, if we close this structure like this, then OH group present in the first carbon atom will be like this. This OH group will be attached with the carbon number 1 if we pull like this. This is the fifth carbon atom. This is the fifth carbon atom, and this is the OH group. This is CH2OH, and this is H. Now, if we exchange it, then we can this one. Initially it is this one. If there is an exchange, then we can draw it as like this. Then we can draw it like this: COH, CHOH, COH, CHOH, HCH2OH. While I am drawing, I may cover some of its portions. So let us repeat. This is the first carbon atom. So this is the double bond O, this is H. This is the second carbon atom. So this is H. Left side uppercase, right side lowercase. Again, left side uppercase OH in the third carbon atom. This is lowercase h. Like that for CHOH. But in the fifth carbon atom there is an OH group. There is an H group. There is an CH2OH group. Now if we pull this one to the first one like that, then it will be here in the ring. So this is OH. Again, this is CH2OH attached with the 5 carbon atom. this one, and this is the 6th carbon atom. And if we exchange this one, the structure will be like that, this structure. So we can now somewhat clearly, this is like so dirty, if we draw this clearly, it will be like that. OH, OH, CH2OH, H. This is D-glucose. This is what? This is D-glucose. Now, what are the alpha forms and beta forms of D-glucose? What are the alpha and beta forms of D-glucose? This is CH2OH. This is CH2OH. And this is the OH group. If the last bottommost CH2OH and the OH group attached to the anomeric carbon atom present in the same plane, then this is B isomer, beta D-glucose. And if they are present in the opposite plane, like this one is OH, this is the lower plane, this is the lower plane, this is the upper plane, then this is alpha D glucose. Now, what will you do if you are asked to write the L glucose? If you are asked to write the structure of the L glucose, this one for L glucose, OH will be this side and H will be this side, right side. So you have to invert just this one. Then it will be L glucose. Now this nomenclature will not you cannot designate this nomenclature as alpha, as due to inversion here CH2OH and OH are present in the same plane. So beta L glucose. This is all about glucose. Now what about the ring structure of fructose? Now what will be about the ring structure of fructose? This is fructose. CH2OH, C double bond O. The remaining part will be same as D-glucose. C OH, C H OH, C H OH, CH2OH. 1, 2, 3, 4, 5, 6. Now this will be 1, CH2OH, 1, 1. Again, this is the second, this is the first carbon atom, this is the second carbon atom. Double bond O is attached to it. Okay, this is the second one. Now there will be some other modification I will tell about later on. Now you have to draw the third position, COH. So this one third, COH. Sorry, I have not written here D fructose, COH. Then this is the fourth carbon, left side uppercase. The similar technique, right side lowercase. Then this one, fifth one, if we turn like this, if we pull this, then we can write this OH here with the fifth carbon. With the second carbon, this one, OH, and this will be the fifth carbon atom. This is the sixth one, CH2H, and in with the fifth there is an H. So H, 5, 6. Now you can here erase the double bond, as you have pulled here and modified this structure, so it will be like that. So I have to explain once more, so because there may be some overlapping while I am writing. You cannot get what I am writing because of this overlapping. So this is the first one, CH2OH. CH2OH is attached to the carbon number 2. In carbon number 2 there is double bond. This is double bond. Let us not discuss about this OH. Simply write the third one by using the previous technique, COH. This one, left side uppercase, right side lowercase. Again, C, left side uppercase, right side lowercase, fourth carbon atom. In the fifth carbon atom there is an OH group. Now we have to pull it. Now you have to pull it to the second position. So this OH group comes from this one. Now this is the sixth carbon atom, CH2OH group here, and this is the fifth. This is the hydrogen atom. So we can clearly draw it like this one. Lastly, you have to erase this double bond. CH2OH, OH, carbon number 1, carbon number 2, OH, H, HOH, third, fourth, fifth, H, CH2OH. Now, this CH2OH in the upper plane, this one, lower plane. So, both plane are different. So, alpha form. Alpha D fructose. What is alpha? What is beta? I have discussed before. This is the anomeric carbon atom. This is the anomeric carbon atom, and this one is the bottommost CH2OH. So, opposite plane, so alpha. And if we reverse it, OH, CH2OH. CH2OH, OH. These are opposites. These are opposite plane. So this one is alpha. This one is alpha. This one is alpha. and previously we have drawn this CH2OH OH, the same plane, therefore beta. Again, if you are asked to draw the structure of L-fructose, suppose you have asked to draw the L-fructose, everything will be remain same, but this one OH come to this side, OH come to this side, and H come to this side. So H will be, it will be like this, HCH2OH, HCH2OH. This is L-fructose. Both planes are opposite, therefore alpha L-fructose. If we change it, it comes to the same plane. It comes to the same plane. Then beta L-fructose. So this is for today. How to draw all the important structures, which is very confusing for your exams. Various types of monosaccharides, glucose, fructose, galactose, mannose. They are D forms, L from same structure, ring structure. Now you can draw all this. Now you can draw all this very easily with this simple trick by simply completely remembering only one structure, that is of D-glucose, and you have to draw all these structures by relating with the structure of D-glucose. So this is for today. Thank you. Have a nice day, and I hope you will give your important feedback so I can modify my delivering style in my next lecture. Thank you. Have a nice day.